Okay, hello, welcome to section 5.6, factoring trinomials. Now the last section, which was misnamed as 6.1, but it was talking about factoring in general, factoring what is factoring, factoring is undoing multiplication, right? And it was talking about greatest common factor and factoring by grouping, both excellent starter methods. 5.6 is about factoring a specific type of polynomial. While greatest common factor will work for everything, the most often used factoring route is factoring trinomials. So just a quick reminder, what is a trinomial? Well, a trinomial looks like this. Looks just like that, right? Has three, hence trinomial. Usually we deal with the quadratic form of this, the x squared, single x, and a constant. That doesn't necessarily make it a trinomial. Trinomial just means it has a degree of 2. You can ignore that definition, pardon me. That is not a degree of 2. It has 3 terms. It has a degree of 2 if it's a quadratic. This one is the most interesting, and it's probably been taught to you quite a few times. It is all about being able to undo stuff. And you may be thinking, gosh, I hate factoring. What is the point? Who cares? But factoring here that these trinomials, not only does it let us deal with quadratics, which, depending on your career, you may need or may not need, but it's a really good approach in how to undo a problem. Okay, think about a giant knot. No matter what in life, there's going to be knots, metaphorical knots that you have to undo. And so this, the reason almost I'm not going to say almost every state in the United States and almost every country in Europe makes you teach factoring is because it is so much more than just factoring. So while you're doing this, yes, it'll be challenging. Yes, it will hurt. Yes, you have to practice. Sorry, welcome to life. But it's all about undoing it. So if we look at trinomials, right, we said 3. But if we go back to what it was before, let's not look at the trinomial, let's look at the factored form. The factored form of this is x plus 3 times x plus 5. But what if this was the original problem? If this was the original problem, and I said multiply, okay, we're back in 5.4 or something. Well, you know how to do that. You multiply it out, and just like in 5.4, I don't care how you organize it, do whatever you want, use the box, don't use the box, use FOIL, don't use FOIL, I don't care. But basically, at the end of the day, x times x, you get x squared. X times 5, you get 5x. 3 times x, you get 3x. And 3 times 5, you get 15. So you're doing each case, right? You're doing each case and you're getting these 4 terms. But then it happens to be the case that 2 of them are like terms, the middle 2. Doesn't necessarily have to be the middle 2, but it could. In this case, it's the middle 2. They add together to get our trinomial of 8. Now what factoring is going backwards. We're saying, what were those 4 things that we got when multiplying? What were the 2 polynomials? So all factoring is going this way. Okay. There are a multitude of ways that you probably have been taught this. Some people use an X, some people use a table, some people use a box, some people use some weird form of grouping. I personally use a weird form of grouping sometimes if I can't figure something out. But it's all about thinking logically. It doesn't have steps. There are no steps to solving a trinomial. And I know I say that when down here it says steps to solving a trinomial. But it's all about going backwards. You got to go backwards. How do you go backwards? So let's take a look at this one. Now I know some of you out there are like, well, what multiplies -35 and has 2? Oh, it's this, I'm done. And you have no idea what you're actually doing. Okay, so if this is boring, ask yourself, do I know why? Do I know why I'm doing it this way, even if I'm getting the right answer? Because you can bet $100 million that that's going to be on your test. Okay? Alright, let's think about this a little differently. So the question here is actually the answer. This is the answer. Y squared plus 2y minus 35. This is our answer. What was our question is the question. What was the multiplication that gave me that? Now you can organize your thinking in any way what you want. I like to start with the end. Okay, if you don't like my way of thinking, you do it yourself. But let's start with the end. This last one had to come from these 2 last ones. That's how the FOIL part works, right? In our original example, we had 3 times 5 gave us 15. That's where this 15 came from. It's the only part that's not going to have a y on it. Or in this case, an x. In this part, it's the only part that's not going to have a y on it. So what are my options here? My options here would be, well, 1 and 35. One of them is going to be negative. I'm not really going to put that part in yet. Or it could be 5 and 7. Okay, those are my options. Those are what could be there. Now I've just whittled every single number in the universe down to 2 pairs. So that's a really convenient place to start, right? My other question is, well, I have a different question. The second question, what gave me y squared? There I have even fewer options. The only thing that can give you y squared is y and y. Okay, and that's what had to be first, y and y. Okay, so those are my options there. Now the last question, so question number 1, question number 2, and now the last question is, what combination gave me 2y? Okay, that's the question. Or no, that was the answer. That was my answer, was 2y. Just like here, the answer was 8x, but that's not what we got when we multiplied. We got 3 and 5, right? We had 3 and 5, they became 8. Here, I got 2 out of 2 things that will be added together, right? I got 2 out of 2 things that are going to be added together. So the question is, what were those 2 things? Well, those 2 things had to be some combination of these. Obviously, they had to be y's, right? They had to have y's on them. That came from y times y. But which one of them is going to add to 7? Now remember, this is a negative 35, so we have kind of a negative to throw somewhere in here, right? So which combination is going to add to negative 35? I think that might be 5 and 7. Sorry, it's going to add to 2. How do I get this to add to positive 2? Negative 5. That's what gave me 2y. So, this is what I'm saying. My first had to be y and y. My last had to be 5, negative 5, and 7, because the 4 combinations I get from that, y squared minus 5y plus 7y minus 35, are what gave me my answer. Okay, so my question is this. Alright, now that's really abstract, and I hate to say this because it's going to panic a couple of you guys, but that is college level thinking. This is college. In a nutshell, this is a college math class, taking something one way and going backwards. That's all this is, though, if you really look at it. You guys know how to multiply. I know you do. Almost 99.99% of people reach senior year and can multiply 2 polynomials. And if that's not you, then come see me and I will make you part of that 99%. Okay? But so all this is going backwards. You're undoing it. Okay? You have to have a deep understanding of what you're doing when you multiply. So now, if we kind of test this out, we'll just do a couple where we go backwards now. Right? I take y minus 5, y plus 7. Now we chose y to begin with because that's how we're going to get our y times y is y squared, right? And then the last part, we chose this pair, 5 and 7, because we know the last part's going to equal negative 35, right? Could have been 1 and 35, but we didn't choose that pair because we know in the middle we had to get this combination. And looks like, when I do my insides-outsides, that is what I get. And when I add those middle terms together, I got what we started with. So we're just going backwards now. We just went this way instead of this way. All right, so let's try it again. We'll do a fresh one. Again, it's not really a step kind of thing. You can use any organizational method you like. Okay, if you were taught a different way to do this with grouping, it looks a little different, and that's fine. You'll end up the same answer. If you were taught with a box or an X or a table, please continue to use that. I'm not saying you have to abandon anything that makes sense to you, okay? But it's not a step-by-step process. So let's just let's ask the question. Here's the answer. What was the question? Okay, I'm going to put little parentheses down here, because that was the question. What was the question that multiplied out to this trinomial? What were the two binomials that multiplied out to this binomial? Well, to get x squared, it had to be x and x. There's no other way to get x squared. So that's just how it had to be, x and x. 72 has a few options, a few more options there. We've got 1 and 72, and again, it's negative, so it could be -1, -72, or +1, -72, whatever. There's 2 and... Ooh, I don't know. It's even, so I know it does. 36. 3 and 24? Yeah. 3 and 24. 4? I don't think so. Nope, I'm wrong. 4 and 18. 6 and 12. 8 and 9. Those are all the factors, hence factoring, of 72. Right, so I have a lot more options here than I did in the last one. That's okay. I've still narrowed it down to 1, 2, 3, 6 choices instead of infinite number of choices, right? Okay. Any of those combinations could go in the last two, so I don't write anything yet. But the last question, what added to 1x? So this is my last question. So 1x, what gave me that? Okay, 1 and 72 are obviously way too far to ever add to 1. I could look around this whole list, but I'm looking at this guy right here, and I kind of have a gut feeling. Those are about a 1 apart. So let me look at this. Is there any way to get an 8x and a 9x add to positive 1? I could do that if this was a negative 8x. So those must be what were in the middle and added to those. So it looks like this must be what's on the end. And again, it is not just because those add to 72, or sorry, those multiply to 72 and add to 1. Okay, you can't whittle this down to a quick remembering thing. It's not a step, it's not a trick. You are asking yourself, what multiplied to the very last thing here, and what combined to the middle? Okay, so this is our factored form. Now, great thing about factoring is since I know how to multiply, I can double check real fast. There's no reason to miss any points on this next test because you can always double check your answer real fast. If I just multiply those out, I should get back where I started. Plus 9x minus 8x plus, minus 72. Add them together, I get x squared plus x minus 72, which is what I started with. So I know that that must have been my factored form. This is where my question was. That was my question, so now I got the answer. Okay. Moving right along. Quite a few more of these. Let's try this one out. Try this one out on your own, see if you can come up with the factored form. Again, organize it however you want, but give yourself a minute to try it on your own. Make sure you pause the video. Okay, so the video is paused, hopefully. If you factored this, I hope you saw that these multiply into 6 and 8. Well, sorry, it factors into 6 and 8. This is t and t. And, if you have a gut feeling about one, go for it. You don't need to list all of the factors. If you already see 48, 6, and 8, and they add to 14, that's great. Go with it. Make it efficient. You don't need to write out all these numbers. Again, it's not about steps. You're just trying to find what would multiply out and get you the thing you started with. T plus 6 and t plus 8, when we multiply that out, we get t squared, 6t, 8t, and 48, and the combination would be 14t. So we have gone backwards, we found the factored form. Notice it wasn't a lot of writing, it wasn't a lot of steps, it was intuitive, and it's gonna take a while for this to be intuitive. If you have a lot of writing on your page, great, that's the first step. But as the more you do these, the better they get. And that is also just a sad fact of factoring, is you have to practice. You have to practice getting good at this. Okay, next one. Multiplies to 7 and m squared. Well, it multiplies to this thing. Let's say that multiplies to this thing. M and m would be m squared. M and m. 7. 7 and 1. I could try 1 and 7. There are always factors. Don't think that just because it's prime doesn't mean it has factors. The problem is it's positive 7. So either it's 1 and 7 or negative 1 and negative 7, and neither one of those adds to 6. It's really close. If one of them was negative, we can make it work. But then I'd have minus 7 on the end. And so this isn't actually going to factor. There is no combination of binomials that will work. This is what we call unfactorable, or something that only has a factor of 1 in itself, prime. prime. Alright, cool. So those happen. Unfortunately, they happen quite a lot. In chapter, we have a lot to deal with until we get to you actually unraveling those. And when we hit chapter 8, that's when we will finally kind of divulge those apart. We're using some other methods, but right now, we're just going to call them prime. Okay, here we have one here. This one looks a little different, right? But like I said, this section's called factoring trinomials, not factoring quadratics, because we can actually apply this idea elsewhere. This is still quadratic-esque, right? It just has squares on both ends. It's not going to actually change anything, though, because we're just asking the question, what is going to give us this thing? Well, to get p squared, I would need a p and a p. Over here, 16a squared, I know I'm going to need an a somewhere, right? But then there's a bunch of things for 16. There's 1 and 16. It could have been 2a and 8a. Could have been 4a and 4a. I think that's pretty much it, right? So now we're looking at these and we're trying to think what combination is going to give me that 6ap in the middle, right? Okay, so now, not 1 and 16, I think 2 and 8. If I were to have, let's see, it's positive 6, so positive 8a and negative 2a. So even though it has an 8, the a is on the end, right, it doesn't really matter because all we're talking about is what would multiply out. If I try really hard to think about this as a series of steps, I'm going to run into a lot of snags when I hit stuff like this. Excuse me. It's going to scare me. Okay, so don't think about this as steps. Think about it as what would multiply to 16a. Okay, my options are on the page. Now, what of those, when multiplied to p, to each of those p's, would combine to 6ap, right? What is going to combine? And we found it. We do a quick little double check. If we don't trust ourselves, right, we go over here. P plus 8a, p minus 2a. Multiply, we get p squared plus 8ap minus 2ap minus 16a squared, and we see that the middle combines to 6ap. All right. There we go. So I just proved it. Now I'm not going to box that because that's not my answer, right? My answer is the factor form, or my solution, my point giver. I don't call it an answer because that's, you know what I mean. Okay. Last one. So what can I do here? Well, I can't do much because it's a cubic, right? This is working for quadratics right now. But it's this idea of undoing is still a good idea. I'm still going to undo it. The first thing I notice I can undo is I can take out that y that was multiplied to everything. In fact, I even see a little more than that. I see 16 multiplied to everything. So if I start with the very first one I learned, GCF, I can factor that out. And then I get y squared minus 2y minus 3. There you go. I've factored it. Have I finished factoring it? No, there's still more that I can do, but that is factoring. I've undone, I've taken out this thing they had in common, right? Now I can keep going. I can keep undoing this multiplication. All right, let's get this. So has to be y and y. Let's see, for 3, negative 3, it has to either be 1 and negative 3 or negative 1 and 3. And when I multiply each of those to y to get negative 2y, it's going to have to be negative 3 and positive 1. Drag that 16y down, and we're done. All right. Cool. Okay, moving right along. We're going to do some more. Just the same idea. People section these out. I don't think they should be sectioned out. These are not any different. Okay. However, if you think about this in terms of steps, you may have noticed that the last 5 problems we've done, everything is started with an m squared, t squared, r squared, q squared, p squared, right? It's nothing, there's no first factor. This is what we call a not equal to 1. If you remember, our standard form is ax, standard usually starts ax squared plus bx plus c, right? This, just a is not equal to 1. So we have 12r squared. In the next one, you'll see a 3x squared, a 6p squared. But it's not any different. If you try to use a method, if you try to use a bunch of steps, it will be different. And that's really inconvenient for you because you have to remember all these things. So if instead you just be the adult that I know you are, be the logical thinker I know you are, and I know you are. If you didn't, you'd probably be dead by now. If you didn't have any logic to you whatsoever, you would have stuck your finger in a light socket long ago and not have been in this class. So you are definitely a logical person. Use logic and answer the question. Or find the question. What was the question? It's just now we're not guaranteed that it's R&R to start with. Okay, if I wasn't relying on that fact, it shouldn't matter. If I was relying on that fact, that's going to be really annoying to have to deal with. But I'm not relying on that fact. Let's just start with the back. What was the last? Well, 1 and 2. Some combination of 1 and 2. Either this one, or it was the other negative. Right? Okay. That's not too bad. Right? Now we have to think about 12. 12r squared. So these all have r's on them. That's how we get r squared. But 12 is a few more factors than 2. So let's write them over here. 12r squared. How are we going to get this? We could do 1r, 12r. That would give me r squared. 2r and 6r would give me r squared. 12r squared. 3r and 4r would give me 12r squared. And I think that's just about it. Okay, so it's not super bad, right? We had 72, and that was a lot more factors. Here is just 3. Okay, so now I've got, this is my front, this is the last, right? Now I'm looking for a combination between these of -5. This is where it gets a little tricky, right? It's getting a little tricky. So now maybe I want to write these off to the side because I got more to think about now. I don't just have some number. I don't have 2 numbers. I kind of have 4 numbers. So let's look at this. 5. If I had just kind of a test one, 1r plus 1 and 12r minus 2. So I'm going with the first combinations for both, right? My firsts and my lasts. Sorry that I wrote them backwards. Does it work? How could I check it? I could multiply it. Now I know the first are going to work. That's going to give me 12 and that's going to give me -2. I don't really care about that because that's the number. That's how I chose these numbers to begin with. I know that part's going to work. I'm just going to look at the outsides and insides. Now if you are working in pen right now, I strongly recommend you switch to a pencil or you're going to be really annoyed. Okay, -2r plus 12r. Those insides do not give me -5. So it could not have been this combination. Now before I move on, I want to try instead, maybe it's the other way around. Maybe it's in fact 12 and 1. Maybe that was different. You're going to think, Miss K, that's the same thing, right? It's just going to be the negative version? No, it's not, because when I do it this way, it would be... Sorry, that one is backwards because I wrote them both backwards. What would it be if it was... No, it isn't. I was totally right. Just kidding. Okay, so this one would be 24 and 1. What happened to my colors? Oh, just kidding. There we go. Okay. So this one would be -24 plus 1. Now that also does not give me 5, but notice those are not the same. So I have to consider switching places as well. This is where it gets challenging. I will give you that. You have to practice. Okay, so it's not this combination, so obviously not the 12. Now do I have a gut feeling about something else? I don't have a gut feeling about 2, 6, but I have a gut feeling about 3, 4 because I've done these. And I've developed a gut feeling, right? You don't develop a sense of playing the piano overnight. But I'm going to try these ones out. I'm just going to try it. Maybe I'm wrong. I don't know. Could be that it was supposed to be 6 and 2. But I'm just going to try this one. So notice I'm erasing my work. I don't really care that I made a mistake the first time. Let's do... We'll do 4r minus 3 and 2r... No, not 3. 3 is not an option. Minus 2 and 3r plus 1. Okay, I'm going to go with that combination. Maybe I'm right, maybe I'm not. Looking at this, 4 minus 6. Yeah, that didn't work. Okay, so it's not that one. All right, but I still have a gut feeling about this one. So maybe it's... maybe it's the other way around. 1 and 2. Okay, that gives me 8r minus 3r. Hey, that's 5r. So close. I need negative 5r. So it must be the case that it was this way. And I'm done. As soon as you found it, you're done. As soon as you found it, you're good. That sounds interesting. But as soon as you found that middle one, you have found the whole thing. I have factored. Now again, there's 47 other ways to do this. They're probably more complicated. And if you didn't follow that, there's a high probability you didn't follow that because you're watching me think. You can't watch someone think. You have to wrestle with it yourself. You have to understand where you're supposed to go. What were you supposed to get? I'm supposed to get 12r squared minus 5r minus 2. How do I get that is the big question. How do I get that? I can get that by having a 4 and a 3 to give me 12. I can get that by having a negative 2 come from 1 and negative 2. And I can get negative 5r from negative 8 and positive 3. I can get that from there. But notice it's really easy to figure that out once you see it, right? Once you can actually multiply those out. You have to play with the numbers. You have to. Okay, so let's try another one. Pause the video and try this one on your own. See if you can undo this multiplication into its factored form. Okay, hopefully you had a chance to try it out. These numbers not nearly as bad as 12, not nearly as many combinations. Here we have 3 and 1. Sorry, pardon me. We have 3x and 1x. That's how we get 3x squared. Pretty much the only combination. 2, 1 and 2. It's the only thing we can do. So now we don't have a lot to check. It's either 3x plus 1 or 3x plus 2. Let's try 3x plus 2 and 1x plus 1. Does that work? 3 and 2 makes 5, not 7x. That sucks. So instead of that, let's try another one. How about 3x plus 1 and 2x plus 1? We get 6. No, not 2x plus 1. Sorry. 1x plus 2. We get 3. No. On the outside, we get 6, and 1 makes 7. So we're done. 3x times 1x gave me the 3x squared. 1 times 2 gave me the 2. And then my outsides gave me 6x. My insides gave me 1x. And together, that's 7x. That's how I undid it. Maybe you had more writing. That's okay. All right, let's try another one. Okay, here we have 1p and 6p, or 2p and 3p. Ooh, before that, I think I want to make my life easier. I'm noticing that these are all even, because I was about to write a bunch of 2's for the other one as well. So I'm going to take out a 2. 3p squared plus p minus 4. I'm going to do this problem twice, one where I saw that and one where I didn't. Okay, I'm going to show you the difference between the two. So now I'm here. 1 times 3p, just kidding, 1p times 3p, my only options, 1 times 4, 2 times 2, my only options there. What combination is going to add to 1? Let's see. 3 and 4 give me 12, don't want that. Probably some combination of 2's. Oh, there's a negative in there. Okay, so there's a negative in there. So one of these has negatives on it. Thinking 8 and 3 would give me 5. Nope. No, 4 and 3. Yeah, let's do 4 and 3. So it's actually, I think, this one, because I could get a 4 and a 3, and a 4 and a 3 would be 2. So 1p minus 1 and 3p minus 4 give me 3 and 4. I need positive p, so positive 4. Okay, and so my final answer would be 2 times p minus 1, 3p plus 4. How do I know that? Because 3p squared, 4p, minus 3p is 1p, and negative 4. I got back where I started. All right, so now let's pretend I didn't see that. Let's pretend I didn't see the 2. Kind of, geez, sorry. So we're back here at the beginning. 6p squared plus 2p minus 8. I could do this without factoring out that 2, but I would end up with more options. 1p and 6p, 2p and 3p. Here I'd have 1, 8, 2, 4. Yeah, that's it. Now what combination multiplies to 6? I'm sorry, adds to 2, pardon me. Combination multiplies, adds to 2. 6 and 8. 1p plus 1, 6p plus 8, and this is a minus 8. So one of these is actually going to be negative. To get a negative, positive 2, it's going to have to be a positive 8. That would give me 6p squared, 8p, minus 6p is 2p, minus 8. So that would be my final form. But then if you look at that, there's another GCF of 2 in here. And I would actually lose points for not, you're going to hate me, but I'm going to drag and drop this whole thing. I would actually lose points for not taking that common factor out. Here we are. So this would not be my final answer. I would need to take that common factor out to 3p plus 4 and p minus 1. And now we see that it would not matter whether I take that 2 out at the beginning or take it out at the end, but it has to come out. Notice it was actually kind of easier to look at 3 and 4 than it is to look at 6 and 8. You could argue it wasn't easier, you could argue it was the exact same. Some problems it'll be much easier, some probably really won't matter. But I recommend you always take it out first. Excuse me, did not get sleep last night. Okay, this next one's pretty much exactly the same. So we're going to kind of skip it. Actually, no, I'll do this one because this is the help video. It is going to be quite a long video, but it's the help video. So if you wanted to skip over this one, you could. This and the next one, and probably the one after that, are all pretty much the same. So for extra practice, I recommend you pause the video and do them on your own. All right, for this one, I'm going to start by taking out a 3, because that would be really convenient for me. X squared plus 4x plus 4. Now I'm going to try and figure out what multiplies to x squared. That would be x and x. And again, I'm not looking at this as, oh my gosh, there's no a anymore. Now it's back to that other routine, because that's too much to think about. I just want to logic my way through this. The only way to get a single x squared is x times x. Think of it as 1 times 1. Right, that's all. There's only options, so it's just got easier. 1 and 4, 2 and 2. Oops. So I'm going to think 2 and 2. Because 2 and 2 not only multiply to 4, but when I do 2x times 2x, I add those together, I get 4x. And so I have factored. Like I said, not the best problem, but it's okay. All right, here we go. This one's a little bigger. Unfortunately, 19 is prime, so there is nothing to take out here. That kind of stinks, but that's okay. We can work with this one. So I've got 1m and 18m as an option, 2m, 9m as an option. Come on. And then 3m, 6m as an option, 4, 5. Nope, and that's the options. Okay, so for x, I've got 1 and 12, 2 and 6, 3 and 4. And each of them would have an x on it. So I'm just listing out my options, right? The second one is negative. Now I need some combination of these that will add to negative 19. And here's where I'm going to kind of play around. So I'll go over here. What do I have a feeling about? Let's go with, no, 9 and 6 give me 54, but 9 would be 18 and 2 would be 12, no. 4 and 6 would be 24 and 9. 24 and 9? Is that 19? No, that's 13. Just kidding. 18 and 12? No. How about 18? No. 18 and 6? I don't know. Let's just pick one. Let's do... Okay, let's do 3m and 6m and 2x and 6x. And one of them has to be negative, so why not that one? I have no idea if this combination works. It's probably not going to. So if I multiply that out, just the first and last, I know, or the outsides and the insides, I know are going to work. No, just kidding. The first and the last, I know are going to work. That's how I got these lists. It's the inside and the outside that I want. So here I get negative 18x plus, well, mx actually. mx plus 12mx, which is negative 6. That is not negative 19. Okay, so that combination didn't work. I'm going to mentally check the other one now. If I put the 6 here, that would be 6 times 6 is 36, and 6. No, hold on. Let me actually write it down. If I put the 6m here and the 3m there, then I get negative 36 and 6, and that would be 30. Not quite. Okay, so we know it's not that one. Okie dokie. It's going to take a minute. It's not that combination. Okay. 24 and 9. It's 15. Closer. How about 54 and 4, 18 and 12. 54 and 4, 18, let's see. 18 times 4, it's 3. Nope, too much. Okay, 12 and 9 is 72 and 2. 24 and 9. 18 and 12, 36 and 6. Let's see, 24 and 8. Ooh. 4 minus 8, 16. Close. Oh wait, that's 27. 9 times 3 is 27 minus 8 is 19. Hey, I found it. Okay, so after kind of mentally running through these ones, I have found, with that same skill, that same logic I just did with the bubbles, okay, I just did them in my head, and yes, that is practice, I found that these two will help me out. If I do 9m and 3x, that's going to give me 27. And if I do 1, oh sorry, just kidding, 1m and 4x, that's going to give me 4. And if I make the 27 negative, I get negative 27mx plus 4mx. I'm sorry. Plus, that's a 2. My apologies, 2. 8. I get negative 19mx. So I found it. So my final factored form is 4m plus 1x, 2m minus 3x. Notice the m's and the x's played into that very little. What was really annoying is 18 and 12 had so many factors. So when they have a lot of factors, you really want to see if you can get a GCF out. If you can't, welcome to life. Sometimes it just kind of sucks. There are going to be some business problems where you struggle on them for a week and you're worried you're going to get fired over it. And it's just going to have to take perseverance. Okay, perseverance is a big key here. You guys can persevere and you can do hard things. Okay, it just takes time. If you needed to write every single one of those out, you should. Okay, you should. Just practice and you'll be able to do better. All right, we'll do one more. Well, 2 more before we talk about an extension of this concept. All right. This one, also not super convenient because 2 of them are even, 1 of them's not, and the third one is, or the first one is prime. So, don't really have, well, it's not exactly prime, depends on who you talk to, but I don't have a GCF, regardless. So, let's start doing 1 and 3 are my options. 1 and 12, 2 and 16, and 3 and 4, 2 and 16, try again, 2 and 6. 6 and 3 and 4. Okay, so what of these, I'm sorry, x and x. What of these is going to give me 16? I think 18 and 2. 1x, 3x, 6 and 2. Here's the thing though, my 12 has to be positive. So I know that these both have to be plus. But my 3x, or my first term is actually a negative 3x squared, so the negative place is going to be put in front of the x. Totally illegal maneuver. Not the prettiest, not the most normal connotation. Some people elect to take the negative out. In either case, you'd be okay, as long as you don't drop the negative. The negative has to be there on the outside. I'm not going to, because I think this is a positive 16. I think just putting it next to the negative 1, I can get my answer. Negative 3x squared. Oh my goodness, sorry. Negative 3x squared, negative 2x, plus 18x, plus 12 will give me what I started with. And so this would be my factored form. Okay, this last one here, very similar to one we had before. We do have something we can actually factor here, but notice there's no y on the end of that. Okay, if there's no y on the end, there's no combination that's going to lead us to y squared in the middle. So this would almost be another prime. But you do notice it is even. In fact, it has 8 we can take out. Can't take out any y's. So we end up with 2y cubed plus 3y minus 2. Sorry, 2y squared. So it's not prime per se, because we can take an 8 out. It's just not the most exciting. But there is no combination that would have a constant at the end, a cube in the front, and add to a 2 in the middle. Now there is another way to undo this, but we'll talk about it more in chapter 9. Okay, so that's kind of factoring, just trinomials. We're going to extend this idea a little bit. We're going to do something we call U substitution real fast. Great little tool. Love U substitution. Super exciting. This is the first time you probably ever heard of it. U is completely arbitrary, but it takes horrible looking things and makes them really convenient. So if we look at this one right here, it's 2 quick problems, don't worry. If we look at this one, we can see that it's almost the thing we've been working with for a while. Okay, it's almost something we can factor. We could just simplify this out, right? We could multiply binomial times itself. We could distribute that 5 in. We could distribute the 2 in. We could simplify, and we get down to a quadratic. It would work. But that's a long way around for something we eventually want to undo anyway. So what I'm going to do is I'm going to say, hey, these match. I don't like them matching. No, I do like them matching. I love them matching. I don't like that in particular, though. That's kind of the part that doesn't really jive with me. So I'm going to replace it with y. Substitution. We talked about substitution as a way to deal with linear equations. It deals with quadratic equations as well. I'm going to take it out. So all the pink underlined stuff is now going to be written as y. This is a substitution. And U substitution, that was just the first letter they decided to do this with. It really should be like U substitution, like you choose what to substitute. You are choosing, don't actually write that because it's really awkward looking, but you are choosing what to take out to make your life easier. Now if I look at my problem, that's really not hard a factoring problem. What multiplies to 2? 1 and 2. Multiplies to 2? 1 and 2. So this is 2y plus 2, 1y plus 1. I get 2 plus 2. Well, hold on. Yeah, that's not what I wanted. Just kidding. So 2y plus 1. Sorry, 1y plus 2. There we go. I get 4 and 1 is 5. So now I get my factored form. Now the only thing is I chose y, right? U substitution. So I have to take out that y thing I put in. I have to put back what I took out. And then that's kind of, redundant with all these pluses and minuses and stuff in there, so I'll just clean it up real fast. And then I can combine some like terms. I get 2x plus 7 and x plus 5. Okay, so that's what would have happened had I multiplied the whole thing out and then factored it back. But here I can skip all that multiplying by just replacing the x plus 3 with a letter that I choose, using a method I want to use, and then just putting the ugly part back in. Cool. We can do the same thing with higher powers. So that's kind of also why I mentioned that this may be geared towards quadratics, and we want to eventually bring it to quadratics because we know how to work with it in quadratics, but we can definitely use it for higher powers as well. Here I have a higher power situation. I have this y to the 4th, this y squared. Watch out, this is not the same as this other problem. That was a cube and a 2, right? That was a 3 and a 2. Here I can see a doubling idea here. So if I were to rewrite that 4 as squared squared, I can kind of see what I might want to take out. Y squared. If I make, I don't know, t. T is equal to y squared. Or x if it makes you feel more comfortable. If you like x, just go with x. But then if I have 6t squared plus 7t plus 2, well, I know how to factor that. That one's easier, right? I can do that. Here, that would be 1 and 6, 3 and 2. That would be 1 and 2. And so when I factor that, 3 and 4. That would be, nope, just kidding. 4 and 3, yep. So 3t plus 2 and 2t plus 1 would be my factored form of t, but t is equal to y squared, so I gotta make sure I put that back in. And I have factored this. Notice that was a lot easier by just taking out the squared part. Again, it's going to be a little bit of practice to figure out what you need to take out, but these are the two most generic cases that we'll be working with. Okay, it was a very long video. I'll give you that. But that's factoring. It's factoring. It's going to take practice. I cannot do it for you. You have to practice it yourself. It's probably one of the most important things we're going to do this year. So watch this video as many times as you need, or better yet, come see me with questions. Shoot me an email. Shoot me a Canvas message. Physically come see me during engagement or after school. I will be happy to help you out. Other than that, have fun doing your homework.